So now that we've gone over a few rules for taking derivatives, we can actually go over several specific derivatives. And today we're going to talk a little bit about logarithmic functions. And if you recall from last year, a logarithmic function is a function of the form y equals log base b of x. So b is the base. The answer to this, the y value, is actually going to be equivalent to an exponent. This is the inverse of an exponential function. I don't know if you remember this, but you may or may not. This function right here, this equation that I have right here, if you were to rewrite that, it would be the same as b to the y power is equal to x. So y is the exponent, x is like the answer. We don't really have a special name for it. Now, you don't really technically need to know this stuff in a lot of detail. We're going to focus more on one special type. There's actually two special types of logarithms. The first type of logarithm is, we call it a common logarithm. So if our base is 10, that is, actually rewrite that as y equals log of x. If you don't have a 10 in there, that's, if you don't have a base in there, that's going to be base 10. So this is called our common logarithm. This is not the one that we're going to be using a lot, but it's still good to know. It does appear on as a button on your calculator. The really, really important one, you may remember this from last year, is if your base is equal to e, and that's not a constant, that's not a random variable. E, remember, is about 2.7172-ish. So if that happens, we actually write it as y equals ln of x. And that's our natural logarithm. So we've already talked a little bit about the derivative of e, so we're just going to recall one thing, and that is that the derivative of e to the x is equal to e to the x. So hopefully you remember that one. That's one of our favorite derivatives. It's one of my favorite because it's so incredibly easy. Probably one of your favorites because you don't have to do too much unless you're doing the chain rule, then it is a little bit more work. So now I'm going to give you a few other derivatives that are related to these things. So the first new derivative of the day is the derivative with respect to x of a to the x. And a in this case is a constant, so it could be something like 5 to the x, 3 to the x, 67 to the x. This derivative is equivalent to ln of a times a to the x. So you might realize, you may or may not notice this, but if that a value is equal to e, we have ln of e times e to the x. Ln of e, you may remember this, you may not. Remember, ln of e is the same as log base e, and that's equal to 1. So that's something just to keep at the back of your mind. So if that a value is equal to e, that's our e to the x. So this is a more general version of our exponential derivative that we did before. So I'm going to give you the more general logarithm one, which we're going to use occasionally, but not very often. And then I'm going to give you the specific one for ln that we're going to use all the time. So first of all, the derivative of log with a base b, log base b of x, is going to be equal to 1 over x times the natural log of your base. So now, if you think about, like, okay, well, if b was equal to our e value, you would get that the derivative of that would be equal to 1 over x times ln of e. Again, remember, ln of e equals 1. So actually, you don't really need to write down the stuff I wrote on this side. That's just a little extra stuff. You can if you want, though. my derivative with respect to x of my ln of x, log base e of x, is just going to be equal to 1 over x. This one's really important. You will see it quite frequently. And the ln derivative pairs really well with the chain rule, so you're going to be using the chain rule a lot. You might also be using the product rule and quotient rule. Whenever you have to take a derivative, look at it carefully first. Try to figure out if you see a product, if you see a quotient, if you see something inside something else. That'll tell you which rule to use, because you tend to use the 3 rules, product, chain, and quotient rule, a lot. Okay, so let's do some examples. You're welcome to pause and try these on your own, or you can just watch and see what I do for this. For number 1, we are differentiating. Just remember, differentiate is a fancy way to say take the derivative. Since we have y equals, I'm going to write the derivative as y prime. So since I have a function inside of my ln, I need to use the chain rule. So my inner function is 5x squared minus 4. My outer function is that ln. So I'm going to start by doing the derivative of the ln portion of it. When I do the derivative of the ln, I do 1 over, remember derivative of ln is 1 over x. So when I use the chain rule though, I do 1 over all of the inside stuff. The next thing I do when doing the chain rule is I multiply the entire thing by the derivative of the inside. So 5x squared minus 4 has a derivative of 10x. So my answer for that one is 10x over 5x squared minus 4. So for number 2, I have a cosine function inside of my natural log. And so since I have f of x, I'm going to write my derivative as f prime of x. I will start by doing my outside derivative. Derivative of ln is 1 over whatever the inside is, so it's going to be 1 over cosine. Then I do the derivative of my inner portion. Derivative of cosine is negative sine of x. Don't forget to write that x, by the way. So I end up getting negative sine x over cosine x. So if you had something like this on the AP exam, this answer for a free response would be sufficient. However, it's very likely that if you saw something like this, it would be a multiple choice, and the answer would actually be listed as negative tangent x. I hope that you recognize that one. That one's one of the more common trig identities. So for 3 and 4, these types of problems are less common, but that doesn't necessarily make them any less important. For number 3, I want you to notice that this is what we call the common logarithm. Since I have no base listed, it actually has a base of 10. So when I find my derivative of that, I end up getting 1 over, so now I'm going to do, remember the derivative of log. You might actually have this in front of you, so you don't need me to write it down, is 1 over x times ln of the base. So I'm going to do 1 over the stuff inside, which is 3x minus 1, times ln of the base. So that's my derivative of my outside. However, I now need to do the derivative of the inside. So that's going to be the derivative of 3x minus 1, which is just 3. So my derivative of this one is actually 3 over 3x minus 1 times ln of 10. For number 4, I want you to be very careful about this. This mistake I get is really common in like algebra and lower level classes, but I also see it in calculus. Most common mistake I see for this type of thing is people write this as 20 to the x power. And it seems like it should be 20 to the x, but keep in mind that when you have things with exponents, you can only combine them if they actually have the same exponent. So like if this was 5 to the x, times 4 to the x. That would be 20x. But this is not 5 to the x times 4 to the x. This is 5 times 4 to the x. So we are not allowed to do that. So please, please, please do not do that. So we don't change anything when we start this out. When we take the derivative, that 5 is just a constant out front. From there, we actually have a formula, and the formula is, you probably have it written in front of you, so you don't really need to write it down. Formula is that the derivative of a to the x is ln of a times a to the x. Again, this is something you can't simplify. So I end up getting 5 times ln of 4 times 4 to the x. There is actually nothing here that you can simplify, so please don't try to simplify anything. The only thing that you might be able to simplify is if you have a calculator, you can multiply the 5 and the ln 4. But other than that, there's nothing that you can do to make it more simple. So just leave it written out like that.